Okay, today is 4.4. This is counting, so it sounds really simple, doesn't it? I hope you enjoy it. Make sure you have your calculator. You will need it. And let's see what we're going to learn about counting. We're going to do a fundamental counting rule, which, believe it or not, you already know, just not by that name. What factorials are. Some of you do know those. That's the exclamation point. Some of you do not. A permutation and a combination. So when does order matter when I'm counting, and when does order not matter? Okay, multiplication rule just means we have a sequence of events occurring n1 times, and then we have a second one that's n2 times, and a third one that's n3 times. To find the total number outcome, you just multiply them all together. And it will tell you how many total you have. So we have different single scoop ice cream cones at the ice cream parlor, right? I have 4 choices of cones. I'm making these up, I don't really know. 15 different ice creams and 5 toppings to choose from. So when I do that, I just multiply my 4 cones times my 15 ice creams times my 5 toppings, and there are 300 different ice cream cones that can be made. Now, what is the probability that Caden makes my very favorite ice cream cone without me telling him what I want? It's 1 out of 300 because only one of those is my favorite ice cream. Kind of a trick question. I don't eat ice cream. All right. When making random guesses for an unknown 4-digit passcode, so we have 4 digits here. All right. Pause and see if you can get this one right. Okay. I hope you did well. You should have realized from 0 to 9 there are 10 numbers, right? Because 0 counts. And since I can use the same number over and over and over again, I have 10 choices for all 4 digits. So you just multiply those up, and there's 10,000 different passcodes. So the chance of you getting it right on the first time without knowing is 1 in 10,000. In other words, not very good, but possible. Factorial. This is an arrangement of numbers. It's always written in factorial is how you write it. The n stands for a number, like 4 factorial is how it would be said. This is the factorial symbol. By definition, 0 factorial is equal to 1. All right, that's a definition to make our things work better. So realize that 0 factorial is not 0. All right, let's go down here and see if we can figure this out. Factorial means, I forgot to write this in. So 4 means 4 times 3 times 2 times 1. This is where you start, and you multiply every number underneath it in order until you get down to 1, and that gives you your answer, what 4 factorial is. All right, your stocking shelves. You must put back a cake mix, peanut butter, batteries, and a can of corn. All right, so you are putting back 4 different items, right? There are 4 items here. Okay, how many different ways can you put the items back in the proper place? So when you think about it, I have 4 things to choose from the first time. I have put 1 away, so there's 3 left to put away. I put 1 back, I have 2 left to put away. I put 1 of those back, I'm back to 1. 4 factorial is how this is written. All right, and the answer is 24 different ways to walk through the store to put those away. So what's the probability that you took the longest route possible to do so? So you took your time. There's only one longest route, and you have 24 ways to do so. So 1 out of 24. So if you're avoiding work, that's probably more than 1 out of 24. You'd probably do it higher than that. But if you want to get done, your odds of luck are 1. Here we go. Does not matter. Permutations, combinations. Does order matter is the question. So that tells you which one of these 2 you're using. So a permutation, so when we arrange our orders, different sequences, the same items are counted separately. All right, so different sequences are counted separately. That means ABC is different than ACB, is different than BAC, is different than BCA, is different than CAB, and CBA. All of those count differently in a permutation, which means order matters. Which order I pick makes a difference. So like when you guys choose your president and vice president for your class and secretary, okay, if you're chosen as president and vice president, treasurer, and you have 3 people, you can have 6 different ways of doing that because whoever's president matters, right? So order matters. Combination, all right, same thing. You have arrangement of items, and the items are counted as being the same this time. So ABC and ACB are identical. These 6 combinations are the same because I had the same 3 items every time. It doesn't matter which order I pick them. So when I pick a committee of people for prom and I choose 5 of you, it doesn't matter which order I choose you in, you're all on the committee, you all have the same power level, correct? Order does not matter in a combination. Permutation, order matters. Combination, order does not matter. This is hard to remember, and I know that. So for permutations, your author uses permutations position. All right, combinations committee is how he remembers it. You have to find some way of remembering. Permutations position, order matters. Combinations committee, order does not matter. So let's go down here. To find a permutation, it's NPR is how this is read. N things, all right, permutation of R. So how many of them are we choosing? So N factorial is the total of people I get to choose from. And N minus R factorial is the total minus how many I want. Okay, let's give this an example. Trifecta is won by selecting the correct horse that finishes first, second, and third. So I have a position, first, second, and third, and I have to choose them in the correct order. All right, the 140th running the Kentucky Derby, there were 19 horses. So I had 19 horses to choose from if I was going to bet. So that's where the 19 factorial is, and that's 19 here because I'm choosing 19 of them. We're doing a permutation because order matters. If you come in first, second, or third are very, very different. Can be the same 3 horses, but first place is very different than second place, correct? So that's where this 19 minus 3 comes from. I'm subtracting out the 3 that I have, and I end up with 5,814 different ways of picking the trifecta. Now, what this means, so you have 19 factorial, right, over truly 16 factorial. So this is 19 times 18 times 17 times 16 times 15 times 14, all the way down to 1. And you're dividing it by 16 times 15 times 14, all the way down to 1. Well, if you look, these guys cancel out, which makes sense. I have 3 positions with horses to choose from. I have 19 horses for the first place. If I subtract 1, I picked 1, I have 18 to choose from the second place, and that means I have 17 horses to choose from in the third place. And that will give you this. So what are your odds of picking the one that will win? All right, and it's 1 out of 5,814. Okay, probably not the best because you're going to take into account like how fast the horses are, how often they have won, things like that. But if they were all equal, this would be your probability of picking that correctly. Okay, pause and try yours. Okay, I hope you did well. You had 23 cross-country runners, so we are choosing 23. Order does matter because we're selecting places, how they come across the finish line. So first is very different than fifth. And I am choosing 5 of my, are the first 5 places. So 23 factorial over 23 minus 5 factorial. And you got 4,037,880 different ways of doing this. When you do this, to choose one of them with knowing nothing, it's 1 out of that amount. Remember, 23 people for the first, 22 for the second, 21 for the third, 20 for the fourth, and 19 for the fifth place. All right, on your calculator, you should have a button. And most of yours will say PRB. This stands for probability. All right, when you click that, you'll have, depending on which one you have, different options. You should see a factorial key. You should see an NPR key. And you'll also see an NCR key. All right, when you do that, factorial right here can be used up here. So you could have went 23, hit your button, and hit the factorial key to get your answer. All right, this one is for your probabilities. You actually have to type in the 23, hit the key, so NPR will show up on your calculator, and tell that you went 5 of them. And it will also give you your answer. I will allow you to use this, but I do want to see the formula written out for your work to get full credit. So I know you understand what it means. Okay, next. Now, this is a little different. Sometimes this is when everything was separate above. Once in a while, you have identical things that can happen, right? So the number of different permutations, N, are available if all N of them are selected without replacement. So I'm going to pick them, I don't put them back. Some of the items are identical to others. So if they are identical, when we choose them, we can't tell. So they don't count as different permutations because they're the same thing. So since they're the same thing, we have to get rid of those identical options. And to do that, we divide by all the identical possibilities. Now the n factorial is how many times they're the same. All right, now let's do this with an example. I think it will help. We are designing a survey. Pollsters repeat questions to see if you're randomly answering or if you are answering them truthfully. Okay, one particular survey has 10 questions, so we're dealing out of 10, right? 2 of the questions are identical to each other. So I have 2 of them that are the same. I have another 3 that are also identical. So if I have 2 questions that are the same and 3 questions that are the same, that's like 5 of those questions that can be reordered differently. So what we do is we say we take the 10 factorial, this is where we're starting, and now I have to divide by this 2 questions that are identical, so that's 2 factorial, and these 3 questions, because that's 6 different ways I can answer those all the same, so they need to go away. So that's 3 factorial. So you multiply these 2 together, that's where this 2 times 6 came from, and you divide your 10 factorial by your 12, and you get there's 302,400 different ways to answer that survey. All right, I want you to use your name. Now, I understand, so you use however much of your name you need to make sure you have double letters. So my last name is Carter, correct? I'm going to give you an example. I have double letters, so I don't need to include my first or middle name. If you do not, include them, please. So when I look at that, there are 6 letters in Carter, 6 factorial. All right, I only have the R that repeats, right? So that would be over, I would have to take out those. So that would be 2 factorial. Now let's say I'm going to do this a little differently. I am going to include Mrs. Carter. All right, now this time I have, 6, 7, 8, 9 letters to choose from. But now I have 3 R's. So instead of dividing by 2 factorial, I would have to divide by 3 factorial. And if I had accidentally had 2 M's, I would have to put a 2 factorial under here also. So pause and do yours and see how many different permutations of your name there are. There's no shortcut for that on the calculator either. All right, combination. Without replacement, this is when order does not matter, right here. So if I choose 5 of you to get a candy bar, it doesn't matter which 5 of you I choose, all 5 of you will get a candy bar, right? If you're first or fifth, your outcome is the same. Okay, when you do that, that is an NCR, how many we're choosing from, a combination, because order does not matter, and how many we are choosing. Now, if you look, it starts out identical to the permutation, right? N factorial over n minus r factorial, because we have that many. Now we have to take out our identical ones, or the r factorial, just like we did above. So we take out the r factorial, and that gives us our total combination. So now let's give you an example. Okay, California's Fantasy 5 lottery. All right, winning the jackpot requires that you select 5 different numbers from 1 to 39. The same 5 numbers must be drawn in the lottery to win. Winning numbers can be drawn in any order. Right here tells us it is a combination because it does not matter which order I select them in. So this is NCR, which is n factorial. Well, our n is, there's 39 numbers to choose from. So 39 factorial over n minus r, well, I'm choosing 5 of them, so our r is 5. So this part would have given us our permutation right here. But now I have to take out my identical combinations, right? So I also have to divide it by 5 factorial. When we do so, we end up with 575,757 different ways of winning this jackpot. What are the odds that you pick these? 1 in that, correct? All right. What would the probability be if the number ranged from 1 to 25? Does it go up or down? Pause and try yours. All right, I hope you did well. 25 is what you're choosing from, correct? You should have had, whoops, this is a 25. Why does it keep erasing on me? Come on, there we go. Minus 5, so 20 factorial over 5 factorial. 53,130 different ways of choosing this. So you have a 1 in 53,130 chance of getting this correct. If you divide that out, that's 0.000018 that you will actually choose the winning 5. Your odds are not very good, people. All right, good luck on your homework. I hope you do well. 38 is a challenge, and so it's a lot of fun. I hope you enjoy it. Don't spend too much time on the last part of it if you get stuck. We'll talk about it later. All right, good luck.